Good morning, Mr. Adam.
Good morning, Mido.
It's very hot today.
Yes, you look tired. I think the rise in temperature will continue for 5 days.
Oh my god. So let's talk about a topic that fits the atmosphere we live in.
I will tell you about the source of the heat that you feel right now.
How?
The sun.
Okay, let's go.
The sun. The sun is the largest object in our solar system, comprising 99.8% of the system's mass. Though it seems huge to us, the sun isn't as large as other types of stars. Our sun, the heart of our solar system, is a yellow dwarf star, a hot ball of glowing gases. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Electric currents in the sun generate a magnetic field that is carried out through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the sun in all directions. The sun is the solar system's star and by far its most massive component. Its large mass, 332,900 Earth masses, which comprises 99.86% of all the mass in the solar system, produces temperatures and densities in its core high enough to sustain nuclear fusion of hydrogen into helium, making it a main sequence star. This releases an enormous amount of energy, mostly radiated into space as electromagnetic radiation peaking in visible light. The sun is a G2-type main sequence star. Hotter main sequence stars are more luminous. The sun's temperature is intermediate between that of the hottest stars and that of the coolest stars. Stars brighter and hotter than the sun are rare, whereas substantially dimmer and cooler stars, known as red dwarfs, make up 85% of the stars in the Milky Way. The sun is a populationized star. It has a higher abundance of elements heavier than hydrogen and helium, metals, in astronomical parlance, than the older population II stars. Elements heavier than hydrogen and helium were formed in the cores of ancient and exploding stars, so the first generation of stars had to die before the universe could be enriched with these atoms. The oldest stars contain few metals, whereas stars born later have more. This high metallicity is thought to have been crucial to the sun's development of a planetary system, because the planets form from the accretion of metals. The sun has inspired mythological stories and cultures around the world since ancient times. More recently, the sun has adorned everything from album covers, such as Sublime's iconic 1992 debut, to packages of raisins. It continues to influence stories in comics, theatrical films, and everything in between. Solar system. Our solar system consists of our star, the sun, and everything bound to it by gravity, the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Dwarf planets such as Pluto, dozens of moons, and millions of asteroids, comets, and meteoroids. Beyond our own solar system, we have discovered thousands of planetary systems orbiting other stars in the Milky Way. 5 spacecraft have achieved enough velocity to eventually travel beyond the boundaries of our solar system. 2 of them reached the unexplored space between the stars after several decades in space. Ever since the discovery of Pluto in 1930, kids grew up learning that the solar system has 9 planets. That all changed in the late 1990s, when astronomers started arguing about whether Pluto was indeed a planet. At a highly controversial decision, the International Astronomical Union ultimately decided in 2006 to designate Pluto as a dwarf planet, reducing the list of the solar system's true planets to just 8. Astronomers, however, are still hunting for another possible planet in our solar system, a true 9th planet, after mathematical evidence of its existence was revealed on January 20, 2016. The alleged Planet 9, also called Planet X, is believed to be about 10 times the mass of Earth and 5,000 times the mass of Pluto. The order of the planets in the solar system, starting nearest the Sun and working outward, is the following: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then the possible planet 9. If you insist on including Pluto, it would come after Neptune on the list. Pluto is truly way out there, and on a wildly tilted, elliptical orbit. The solar system also contains smaller objects. The Asteroid Belt, which lies between the orbits of Mars and Jupiter, mostly contains objects composed, like the terrestrial planets, of rock and metal. Beyond Neptune's orbit lie the Kuiper Belt and Scattered Disk, which are populations of Trans-Neptunian objects composed mostly of ices, and beyond them a newly discovered population of stenoids. Within these populations, some objects are large enough to have rounded under their own gravity, though there is considerable debate as to how many there will prove to be. Such objects are categorized as dwarf planets. The only certain dwarf planet is Pluto, with another Trans-Neptunian object, Eris, expected to be, in the asteroid series, at least close to being a dwarf planet. In addition to these two regions, various other small body populations, including comets, centaurs and interplanetary dust clouds, freely travel between regions. 6 of the planets, the 6 largest possible dwarf planets, and many of the smaller bodies are orbited by natural satellites, usually termed moons, after the moon. Each of the outer planets is encircled by planetary rings of dust and other small objects. The solar wind, a stream of charged particles flowing outwards from the Sun, creates a bubble-like region in the interstellar medium known as the heliosphere. The heliopause is the point at which pressure from the solar wind is equal to the opposing pressure of the interstellar medium. It extends out to the edge of the scattered disk. The Oort cloud, which is thought to be the source for long-period comets, may also exist at a distance roughly 1,000 times further than the heliosphere. The solar system is located 26,000 light-years from the center of the Milky Way galaxy in the Orion Arm, which contains most of the visible stars in the night sky. The nearest stars are within the so-called local bubble, with the closest Proxima Centauri at 4.25 light-years. Inner Solar System. The Inner Solar System is the region comprising the terrestrial planets in the Asteroid Belt. Composed mainly of silicates and metals, the objects of the Inner Solar System are relatively close to the Sun. The radius of this entire region is less than the distance between the orbits of Jupiter and Saturn. This region is also within the frost line, which is a little less than 750 million kilometers, 460 million mi, from the Sun. The planets. The inner 4 planets closest to the Sun, Mercury, Venus, Earth and Mars, are often called the terrestrial planets because their surfaces are rocky. Pluto also has a rocky, albeit frozen, surface but has never been grouped with the 4 terrestrials. The 4 large outer worlds, Jupiter, Saturn, Uranus and Neptune, are sometimes called the Jovian or Jupiter-like planets because of their enormous size relative to the terrestrial planets. They are also mostly made of gases like hydrogen, helium and ammonia rather than of rocky surfaces, although astronomers believe some or all of them may have solid cores. Jupiter and Saturn are sometimes called the gas giants, whereas the more distant Uranus and Neptune have been nicknamed the ice giants. This is because Uranus and Neptune have more atmospheric water and other ice-forming molecules, such as methane, hydrogen sulfide and phosphine, that crystallize into clouds in the planet's frigid conditions, according to the Planetary Society. For perspective, methane crystallizes at -296 Fahrenheit, -183 degrees Celsius, according to the U.S. National Library of Medicine. The 4 terrestrial or inner planets have dense, rocky compositions, few or no moons, and no ring systems. They are composed largely of refractory minerals such as the silicates, which form their crusts and mantles, and metals such as iron and nickel which form their cores. 3 of the 4 inner planets, Venus, Earth and Mars, have atmospheres substantial enough to generate weather. All have impact craters and tectonic surface features, such as rift valleys and volcanoes. The term inner planet should not be confused with inferior planet, which designates those planets that are closer to the Sun than Earth is, that is Mercury and Venus. Mercury. Zipping around the Sun in only 88 days, Mercury is the closest planet to the Sun, and it's also the smallest, only a little bit larger than Earth's moon. Because it's so close to the Sun, about 2/5 the distance between Earth and the Sun, Mercury experiences dramatic changes in its day and night temperatures. Day temperatures can reach a scorching 840 F, 450 C, which is hot enough to melt lead. Meanwhile, on the night side, temperatures drop to -290 F, -180 C. Mercury has a very thin atmosphere of oxygen, sodium, hydrogen, helium and potassium, and can't break up incoming meteors, so its surface is pockmarked with craters, just like the Moon. Over its 4-year mission, NASA's Messenger spacecraft revealed incredible new discoveries that challenged astronomers' expectations. Among those findings was the discovery of water ice and frozen organic compounds at Mercury's North Pole, and that volcanism played a major role in shaping the planet's surface. Venus. Venus, 0.70 100 million kilometers, 65 million mi from the Sun, is close in size to Earth, 0.815 m, and, like Earth, has a thick silicate mantle around an iron core, a substantial atmosphere, and evidence of internal geological activity. It is much drier than Earth, and its atmosphere is 90 times as dense. Venus has no natural satellites. It is the hottest planet, with surface temperatures over 400 degrees Celsius, 752 degrees Fahrenheit, most likely due to the amount of greenhouse gases in the atmosphere. No definitive evidence of current geological activity has been detected on Venus, but it has no magnetic field that would prevent depletion of its substantial atmosphere, which suggests that its atmosphere is being replenished by volcanic eruptions. Venus has a thick, toxic atmosphere filled with carbon dioxide, and it's perpetually shrouded in thick, yellowish clouds of sulfuric acid that trap heat, causing a runaway greenhouse effect. It's the hottest planet in our solar system, even though Mercury is closer to the Sun. Surface temperatures on Venus are about 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead. The surface is a rusty color, and it's peppered with intensely crunched mountains and thousands of large volcanoes. Scientists think it's possible some volcanoes are still active. Venus has crushing air pressure at its surface, more than 90 times that of Earth, similar to the pressure you'd encounter a mile below the ocean on Earth. Another big difference from Earth, Venus rotates on its axis backward, compared to most of the other planets in the solar system. This means that, on Venus, the sun rises in the west and sets in the east, opposite to what we experience on Earth. It's not the only planet in our solar system with such an oddball rotation. Uranus spins on its side. Venus was the first planet to be explored by a spacecraft. NASA's Mariner 2 successfully flew by and scanned the cloud-covered world on December 14, 1962. Since then, numerous spacecraft from the US and other space agencies have explored Venus, including NASA's Magellan, which mapped the planet's surface with radar. Soviet spacecraft made the most successful landings on the surface of Venus to date, but they didn't survive long due to the extreme heat and crushing pressure. An American probe, one of NASA's Pioneer Venus multi-probes, survived for about an hour after impacting the surface in 1978. More recent Venus missions include USA's Venus Express, which orbited from 2006 until 2016, and Japan's Akatsuki Venus Climate Orbiter, orbiting since 2016. NASA's Parker Solar Probe has made multiple flybys of Venus, and on July 11, 2020, the probe came within 516 miles of the surface. In June 2021, 3 new missions to Venus were announced. On June 2, 2021, NASA announced it had selected 2 new missions to Venus as part of the agency's Discovery program. The missions are expected to launch in the 2028 to 2030 timeframe. On June 10, 2021, the European Space Agency (ESA) announced the selection of Envision to make detailed observations of Venus. As a key partner in the mission, NASA is providing the synthetic aperture radar, called VENSER, to make high-resolution measurements of the planet's surface features. Earth. Earth, 150 million kilometers, 93 million mi from the Sun, is the largest and densest of the inner planets, the only one known to have current geological activity, and the only place where life is known to exist. Its liquid hydrosphere is unique among the terrestrial planets, and it is the only planet where plate tectonics has been observed. Earth's atmosphere is radically different from those of the other planets, having been altered by the presence of life to contain 21% free oxygen. It has one natural satellite, the Moon, the only large satellite of a terrestrial planet in the solar system. Mars. Mars is the fourth planet from the Sun, a dusty, cold, desert world with a very thin atmosphere. Mars is also a dynamic planet with seasons, polar ice caps, canyons, extinct volcanoes, and evidence that it was even more active in the past. Mars is one of the most explored bodies in our solar system, and it's the only planet where we've sent rovers to roam the alien landscape. NASA currently has 2 rovers, Curiosity and Perseverance, 1 lander, Insight, and 1 helicopter, Ingenuity, exploring the surface of Mars. Perseverance rover, the largest, most advanced rover NASA has sent to another world, touched down on Mars on February 18, 2021. After a 203-day journey traversing 293 million miles, 472 million kilometers. The Ingenuity helicopter rode to Mars attached to the belly of Perseverance. Perseverance is one of 3 spacecraft that arrived at Mars in 2021. The Hope orbiter from the United Arab Emirates arrived on February 9, 2021. China's Tianwen-1 mission arrived on February 10, 2021, and includes an orbiter, a lander, and a rover. Europa and India also have spacecraft studying Mars from orbit. In May 2021, China became the second nation to ever land successfully on Mars when its Zhurong Mars rover touched down. An international fleet of 8 orbiters is studying the red planet from above, including 3 NASA orbiters, 2001 Mars Odyssey, Mars Reconnaissance Orbiter, and MAVEN. These robotic explorers have found lots of evidence that Mars was much wetter and warmer, with a thicker atmosphere, billions of years ago. Asteroid Belt asteroids, except for the largest, Ceres, are classified as small solar system bodies and are composed mainly of refractory rocky and metallic minerals, with some ice. They range from a few meters to hundreds of kilometers in size. Asteroids smaller than 1 meter are usually called meteoroids and micrometeoroids, grain-sized, depending on different, somewhat arbitrary definitions. The asteroid belt occupies the orbit between Mars and Jupiter, between 2.3 and 3.30, 340 and 490 million kilometers, 210 and 310 million mi from the Sun. It is thought to be remnants from the solar system's formation that failed to coalesce because of the gravitational interference of Jupiter. The asteroid belt contains tens of thousands, possibly millions, of objects over 1 kilometer in diameter. Despite this, the total mass of the asteroid belt is unlikely to be more than 1,000th of that of Earth. The asteroid belt is very sparsely populated. Spacecraft routinely pass through without incident. Ceres, 2.770, 414 million kilometers, 257 million mi, is the largest asteroid, a protoplanet, and a dwarf planet. It has a diameter of slightly under 1,000 kilometers, 620 miles, and a mass large enough for its own gravity to pull it into a spherical shape. Ceres was considered a planet when it was discovered in 1801 and was reclassified to asteroid in the 1850s as further observations revealed additional asteroids. It was classified as a dwarf planet in 2006 when the definition of a planet was created. Jupiter. The 5th planet from the Sun, Jupiter is a giant gas world that is the most massive planet in our solar system, more than twice as massive as all the other planets combined, according to NASA. Its swirling clouds are colorful due to different types of trace gases. A major feature in its swirling clouds is the Great Red Spot, a giant storm more than 10,000 miles wide. It has raged at more than 400 miles per hour for the last 150 years, at least. Jupiter has a strong magnetic field, and with 75 moons, it looks a bit like a miniature solar system. Saturn. The ring jewel of the solar system, Saturn, 9.50, 1.42 billion kilometers, 880 million mi, distinguished by its extensive ring system, has several similarities to Jupiter, such as its atmospheric composition and magnetosphere. Although Saturn has 60% of Jupiter's volume, it is less than a third as massive, at 95 m, as Saturn is the only planet of the solar system that is less dense than water. The rings of Saturn are made up of small ice and rock particles. Saturn has 82 confirmed satellites composed largely of ice. Two of these, Titan and Enceladus, show signs of geological activity. Titan, the second largest moon in the solar system, is larger than Mercury and the only satellite in the solar system with a substantial atmosphere. Uranus. Uranus is the seventh planet from the Sun, and has the third largest diameter in our solar system. It was the first planet found with the aid of a telescope. Uranus was discovered in 1781 by astronomer William Herschel, although he originally thought it was either a comet or a star. It was 2 years later that the object was universally accepted as a new planet, in part because of observations by astronomer Johann Elert Bode. Herschel tried unsuccessfully to name his discovery Georgium Sidus after King George III. Instead, the scientific community accepted Bode's suggestion to name it Uranus, the Greek god of the sky, as suggested by Bode. Neptune. Neptune, 30.10, 4.50 billion kilometers, 2.80 billion mi, though slightly smaller than Uranus, is more massive, 17 m, and hence more dense. It radiates more internal heat, but not as much as Jupiter or Saturn. Neptune has 14 known satellites. The largest, Triton, is geologically active, with geysers of liquid nitrogen. Triton is the only large satellite with a retrograde orbit. Neptune is accompanied in its orbit by several minor planets, termed Neptune Trojans, that are in one resonance with it. Dark, cold, and whipped by supersonic winds, ice giant Neptune is the eighth and most distant planet in our solar system. More than 30 times as far from the Sun as Earth, Neptune is the only planet in our solar system not visible to the naked eye and the first predicted by mathematics before its discovery. In 2011, Neptune completed its first 165-year orbit since its discovery in 1846. NASA's Voyager 2 is the only spacecraft to have visited Neptune up close. It flew past in 1989 on its way out of the solar system. Trans-Neptunian Region. Beyond the orbit of Neptune lies the area of the Trans-Neptunian Region, with the donut-shaped Kuiper Belt, home of Pluto and several other dwarf planets, and an overlapping disk of scattered objects, which is tilted toward the plane of the solar system and reaches much further out than the Kuiper Belt. The entire region is still largely unexplored. It appears to consist overwhelmingly of many thousands of small worlds, the largest having a diameter only a fifth that of Earth and a mass far smaller than that of the Moon, composed mainly of rock and ice. This region is sometimes described as the third zone of the solar system, enclosing the inner and the outer solar system. The Kuiper Belt is a great ring of debris similar to the Asteroid Belt, but consisting mainly of objects composed primarily of ice. It extends between 30 and 50, 4.5 and 7.5 billion kilometers, 2.8 and 4.6 billion mi from the Sun. Though it is estimated to contain anything from dozens to thousands of dwarf planets, it is composed mainly of small solar system bodies. Many of the larger Kuiper Belt objects, such as Quorum, Varuna, and Orcus, may prove to be dwarf planets with further data. There are estimated to be over 100,000 Kuiper Belt objects with a diameter greater than 50 kilometers, 30 miles, but the total mass of the Kuiper Belt is thought to be only a tenth or even 100th the mass of Earth. Many Kuiper Belt objects have multiple satellites, and most have orbits that take them outside the plane of the ecliptic. The Kuiper Belt can be roughly divided into the classical belt and the resonances. Resonances are orbits linked to that of Neptune, for example twice for every 3 Neptune orbits, or once for every 2. The first resonance begins within the orbit of Neptune itself. The classical belt consists of objects having no resonance with Neptune, and extends from roughly 39.4 to 47.70, 5.89 to 7.14 billion kilometers, 3.66 to 4.43 billion mi. Members of the classical Kuiper belt are classified as Cupuanos, after the first of their kind to be discovered, 15,760 Albion, which previously had the provisional designation 1992 QB1, and are still in near-primordial, low-eccentricity orbits. Pluto. Once the 9th planet from the Sun, Pluto is unlike other planets in many respects. It is smaller than Earth's moon. Its orbit is highly elliptical, falling inside Neptune's orbit at some points and far beyond it at others. And Pluto's orbit doesn't fall on the same plane as all the other planets. Instead, it orbits 17.1 degrees above or below. From 1979 until early 1999, Pluto had actually been the 8th planet from the Sun. Then, on February 11, 1999, it crossed Neptune's path and once again became the solar system's most distant planet, until it was redefined as a dwarf planet. It's a cold, rocky world with a tenuous atmosphere. It's clear to me that the solar system saved the best for last, said Alan Stern, New Horizons principal investigator from the Southwest Research Institute, Boulder, Colorado. We could not have explored a more fascinating or scientifically important planet at the edge of our solar system. The New Horizons team worked for 15 years to plan and execute this flyby, and Pluto paid us back in spades. Scientists Mike Brown and Konstantin Batygin at the California Institute of Technology in Pasadena described the evidence for Planet 9 in a study published in the Astronomical Journal. The research is based on mathematical models and computer simulations using observations of 6 other smaller Kuiper belt objects with orbits that aligned in a similar manner. A recent hypothesis proposed September 2019 on the preprint server Arxiv suggests Planet 9 might not be a planet at all. Instead, Jaku Schultz of Durham University and James Unwin of the University of Illinois at Chicago speculate it could be a primordial black hole that formed soon after the Big Bang and that our solar system later captured, according to Newsweek. Unlike black holes that form from the collapse of giant stars, primordial black holes are thought to have formed from gravitational perturbations less than a second after the Big Bang, and this one would be so small, 5 centimeters in diameter, that it would be challenging to detect. Now I'm done with my space tour. Wait for the next video. But before you close, don't forget to subscribe to the channel. Goodbye.